Hello everyone, I'm Frédéric Musselin. I'm an international consultant for École des Ponts Paris Tech and member of Scientific and Pedagogical Council of the Executive Master in Sustainable Real Estate and Buildings. I'm happy to share today a conference which is entitled Continuous Carbon Optimization through Digital Tools. This topic is part of the observatory which has been set up between Low Carbon World and École des Ponts Paris Tech and his Executive Master IBD. And this topic will help you understand how digital can help us decreasing carbon emissions in real estate and buildings. I'm pleased to welcome our three speakers. Two are physically present, and one is seeing us from Vienna. So they are experts in digital, in real estate, buildings, architecture, design, and they will present us their vision, their work, and also very concrete examples on this topic. So I should start to present Arthur Lapeyre. Arthur, you are an architect with practical experience in France, UK, and Spain. You develop strong knowledge in leveraging digital tools, including BIM approach to optimize project management and operations. And recently, you have added to your profile data analyst skills, which help you to understand how building data should be used. Then I will present Angelos Kronis, who is with us from Vienna, Austria. Angelos, I hope you see us and understand us. Hello again.
Hello, I can hear you.
You are head of a city intelligence lab at Austrian Institute of Technology, and you teach at the Institute of Advanced Architecture of Catalonia, and also at the Bauhaus University in Weimar. You studied architecture, and you have previously worked as an associate at Forstner and Partners, and you have been teaching in many different universities all over Europe. Your research mainly focuses on performance-driven design and simulation, but you have worked in various fields, including artificial intelligence, machine learning, 3D scanning, digital fabrication, and interactive installations. You have developed various design systems and simulation interface, including infrared. It's an artificial intelligence-based design frameworks for urban planning that you have launched very recently. Thank you to be here with us. And last but not least, Alfonso Pons Alvarez. You are the development director of RDAI, which is an international architectural practice based in Paris, subsidiary of Hermès company. You represented France at the board of directors of the United Nations Sustainable Buildings Initiative. You also benefit from an extensive experience in all the real estate and sustainability consulting fields. For example, you have worked for Deloitte Real Estate, you have worked for JLL, you have worked for Forstner and Partners in London and Paris. So I think you have a common background in Forstner and Partners, all three. You have published several books, and you have a passion for the analysis of financial externalities from sustainability projects. Finally, you are MRICS Chartered Surveyor, and you are LEED and BREEAM accredited professional. Thank you again for being with us. Let's start with Arthur. You have an extensive experience of leveraging digital tools in conception and construction through your experience, like Forstner and Partners, and you have also a very interesting experience in WeWork. Could you share with us examples of how digital can help us reduce carbon emissions in the building life cycle?
Thank you, Frédéric.
Arthur, the floor is yours. Thank you, Dominique.
So, in a context of succession of digital and sustainable revolution, we will see how the first can serve the second. How the BIM investment over the last 10 years will be useful for sustainable concerns, kind of return on investment. How a continuous carbon optimization is possible through digital tools. rate of carbon must be identified at all steps of the building value chain. Optimization of carbon impact must be done at concept stage, and also building or portfolio sustainable figures must be accessible live to give right indication to decision makers. The only way sustainable development will be massively adopted if it's profitable. In a study developed by Accenture and Dassault from May 2021, we can read that leveraging the use of digital twin for more eco-friendly configuration using big data, simulations, and AI can massively impact our sector. Between now and 2030, more than 288 billion of US dollar and more than 6.9 CO2 emission can be saved. That's the equivalent of 1 year of the transportation sector. So in order to manage, to measure, and to report projects and assets, a lot of technological tools are already here to be used at a large scale. They are not new anymore, and they are affordable for our industry. But construction sector is not ready yet to use this opportunity. As we can see here in a survey made by BCG from 2019 regarding the data maturity by sectors, construction and real estate are not even listed here. Field is large in the construction. Opportunities to leverage technology are huge, but needs to be organized. So to connect all those parts together, more and more AEC firms starts to develop their own tools. Here are some examples of internal applications and platforms developed by Foster & Partners, for instance, with Sandbox, Mott MacDonald with Moata, Bryden Wood with Prisms. Those AEC firms start to develop their own tool for a few reasons. To cover the lack of specific tools, to own the process and own the data also, and to be less dependent to the price. In this movement of developing and coding, the target is for efficiency and soberness. And automation, time-consuming action is key. In here, it's an algorithm developed by the design technology team at WeWork to optimize space to fit as much desk as possible in the room. This is based on the room data, shape, and the door location. That type of generative design tool provides automatically the best option to maximize the building density. Another script developed to optimize the glazed partition layout with all the available modules in stock. Optimization of modules and materials for the execution site. So limitation of waste, which is good for your carbon footprint and good for your budget. Here we try to tackle one of the biggest costs and also the most carbon impactful element in a refurbishment project, mechanical ducts. The algorithm here gives you the most updated layout in terms of linear meters of ducts. So again, less material, without lowering the efficiency of the global system. That's an auto layout using the model data. The practice of BIM in the construction industry has mainly improved during production and site issue anticipation. But the huge opportunity for our sector is about data structuring and data exploitation. With this target, BIM software will not be enough. It will be just one part of a much bigger chain. In this complex map, we can see the different spots of production change improvement. We've got, for instance, project scheduling, document management, real-time monitoring, predictive assets performance. In all those links of the construction chain, AEC companies, contractors, must choose a relevant platform or software. Knowing your target, your business target, and what are your key indicators to monitor, it's important to define and select softwares and applications for all sectors of your production in order to maximize digital tool efficiency. It's also important to select application based on the few features like cost, is the interface user-friendly, is the solution open, and does it fit to your import and export strategy. Basically, any block of your production change should be replaceable, costs can change, and technology will change. In here, we've got an example of a data pipeline built to consolidate different sources of data to build your passport, your building passport, to manage LCA, so analyse de cycle de vie, and also to manage and to have a live vision of your green indicators. So in here, so obviously you've got like inputs coming from your BIM model that's pushed to your main database, where like all the inputs will be merged together and linked through keys. And obviously, so for any kind of business needs, for operation, for instance, you will be merging different sources of information. Here, like your 3D or 2D information coming from the BIM model, and on top you add your operational layer to manage whatever you need for your business. So that's not new, but we can you can also so monitor in a much easier way all your green indicators regarding consumption or carbon weight. That graphs here show you a part of building life cycle and how data should be managed. Structuring only a few green indicators at the beginning is important. It will allow you to successfully deploy the pipeline and gradually spread the data culture in your company or in your department. That scheme here allow you to shows you how an indicator will be more and more reliable based on the project progression and the collection regularity. That's key to diffuse precision and to train your team across all departments. Having almost a live vision on building details and on a portfolio is extremely important. In the same way as knowing directly the budget of an operation, a decision maker must be able to know the carbon footprint of his project with the same precision. Data structuring exercise we saw before can give even more opportunity to our sector when it's come to data processing and data analysis. Opportunity for sustainability assessment, sustainability reporting, optimizing recycling, etc. through data analysis, machine learning, and other techniques. So to summarize, digital tools are ready and should be used to reduce carbon footprint and also create cost cut. Decision-making tools, automation tools to optimize material, time, energy, define ecosystem of applications to monitor your data and analyze them are some levers for the challenge we are facing. And again, the potential is huge. Between now and 2013, more than $288 billion and more than 6.9 gigaton of CO2 emission can be saved. Thank you very much.
Thank you very much, Arthur. We have a clearer vision of how we can leverage digital tools to reduce carbon footprint. I noticed that it's very important to the preparation for data. The data collection is important to improve the use of artificial intelligence in our industry. Something that our next speaker, Angelos Kronis from Vienna, is pushing strongly. So I would like to invite Angelos from Vienna, who is our speaker. Again, thank you for your patience, Angelos. I would like you to share with us your experience and your recent innovation on your new digital design tool, which is quite impressive. And we will help you making decisions using climate change resilience. Angelos, the floor is yours.
Thank you very much for the great introduction and for having me here. I am the head of the City Intelligence Lab, as Frederick said. A couple of words about the City Intelligence Lab. It's a space, but also an intellectual and the physical space in Vienna, at the Austrian Institute of Technology, where we're trying to. It's like an incubator for technology for computational urban planning, we can say. So we're trying to bring cutting-edge technological methods into the urban planning processes, including AI, machine learning, AR, interactive interfaces, and all other things. I'd like to pose a question. How can we design performance? So that's what we're trying to address with infrared. And if we go to the next slide, please. The issue is we have all these different sort of like performance aspects, like the wind, the sun, the pedestrian movement, the networks of movement, and all of that are interlinked in a city and interlinked in our design projects. But the problem is, next slide, please, that they're all quite expensive analysis, quite time-consuming analysis, and they take a lot of like effort, computational and sort of like human effort to address. So how do we bring them all back closer? And this is what infrared is trying to address. Just to give you an example, if we go to the next slide, a typical study for a wind simulation would take a few hours to run, and a typical study for thermal comfort would take perhaps days to run. Which means we can't really afford to have these in a normal design cycle. So what do we do with that? This is where infrared comes in, and I will explain a little bit how we built it, how we work, how we made it work, and then a little bit show. I was hoping to show a live demo here. It's working online. It's been released a couple of weeks ago, but we'll see a short video which is the same. So what is infrared? Next slide, please. This is probably the best image to describe it. You have on one side a horse and the other zebra, and you take the horse and make it into a zebra, and that's done with very elaborate machine learning, deep learning algorithms, or deep fake, or what you call them. Next slide, please. Specifically, we're talking about generative adversarial networks, or GANs. You might have heard of them. They're like very well known. Next slide, please. They are like the ones that take a photograph and turn it into a Monet painting, or a zebra, as I said, a horse and take it into a zebra, or a winter picture, turn it into a summer picture, etc. Probably the most well-known application of that is the next slide, which is when you take yourself and you make it look like your dad, which is a very accurate representation, both in this case and generally, I think. I do like my dad very much here. So what does that all have to do with architecture, urban design, and low carbon? If we go to the next slide, this is probably the most powerful image. On one side, you have a simulation. It takes about 20 to 30 minutes to run. And on the other side, you have a machine learning prediction of that simulation, which is run instantly, a few milliseconds. And that's exactly what infrared is about. We take large simulation data sets and we train machine learning networks, and we have instant answers on performance. So if we go to the next slide, I'll explain a little bit how we built infrared. So we take, in this case, the city of Vienna. Next slide, we parse it. We take the sort of like individual parcels. Next slide, please. And then we, one more slide, please. And then we sort of like create a digital model, a 3D model out of it. And then next slide, we run the simulations, or the solar, in this case, solar radiation simulations, thousands of them. We train a neural network, if we can go to this next slide. And then we sort of like train the network to be able to predict that by using these two pairs. And then we have sort of like the result, next slide, which is like showing on one hand you have like the input, and on the other hand you have the simulation and the prediction, and you can see that they're very, very close together. In this case, we're seeing solar radiation simulations, which are the easiest perhaps to replicate, but we've done a lot of other simulations, training of machine learning models. Next slide, please. I'm sorry, I have to do this every minute. It's different analysis like accessibility, pedestrian movement, wind, which is probably the most important aspect because it's very time consuming, etc. So if we go to the next slide, that's what infrared is about. That's how we built infrared. So infrared is like a framework. It's not like one tool. It's a different, like a collection of different processes, different tools. In this case, we see, for example, infrared working within Grasshopper, within Rhino, and we see a case study we did in Scandinavia, where we have like a sort of waterfront development, and we can see how, you know, the designer can move around the park and immediately see the effect it has on the wind. So you can see this in real time here being updated and seeing sort of like the performance on the left hand, the performance of that site, of how dangerous the winds can be in that location. So if we go to the next slide, so this is infrared now is a web app. You can access it from a browser, and you can directly design there, and it's also connected to, of course, Rhino or other sort of like software, but you can also just directly design online on the cloud. And if we go to the next slide, I'll show you a little bit of like what the demo will look like. So you select a location. In this case, we're looking at Vienna. So you're creating a new project, you're typing your location, and it fetches the data from OpenStreetMap, so it can easily create a context for you before you starting even design. In this case, we are in Vienna International Center, the UN headquarters. And after you select the location, essentially you set your site. Then you can select the different analysis you want to run, as for example, in this case, you give it a name. In this case, we were like looking at wind comfort, wind speed, solar radiation, sunlight hours, which are the models we have developed for Vienna. You can see here the context being sort of like drawn from OpenStreetMaps, and here you select the different variables. So like this is what wind speed and wind sort of like direction I have in this location, and also the solar radiation sunlight hours models, which don't really need any input. We are trying to make all of the sort of like interface easy for people to access it and understand it in the most sort of like straightforward way. And here you actually see a live, like I just shot this yesterday. You click run and you see how fast you get the results of the analysis. So there it's the equivalent of a live demo. So I wanted to not like speed up anything and not tweak anything so that you can see it in its reality. So in a few seconds you will see the analysis popping up on the left hand, and here you see, okay, already we have the solar radiation and the sunlight hours. You can see the different metrics, percentages of different sort of like values on your site. In this case, the sunlight hours, and then here you have wind comfort, the Lawson's criteria, how dangerous or how high the wind is in certain locations. And of course, what you can do is just design on this platform. You can just make, you know, so let's say a prototype for a tower, which I'm going to do right now. And then the idea is that you can very quickly sort of like get feedback, and this sort of like allows you to make informed decisions. The models are like, of course, a prediction. They're like not the exact same thing as running a CFD simulation, but the ability to have this sort of like feedback so early in your design stage is what is, I think, groundbreaking, and what sort of like gives you the ability to design with performance. In this case, we just designed a little tower. It's don't pay too much attention to the design skills of me. And here you can see the result, again, running in real time. This is all, as I said, not spoofed. This was just shot on my computer yesterday. So you see again the different analysis. And we have another step if we go to the next slide, which is comparing different options. So in this case, you have like all the sort of like trees of decisions you made at any point. So like you created a new option, and then from that you created another new option. You can select those ones and compare them and understand how well you're performing and how you're like creating like better or worse performance depending on your design decisions. And that's, I think, also what is groundbreaking. Infrared, if we go to the next slide, please, I'm going to try to wrap up quickly so that I don't take too much time. Infrared is not just working on our web app or Rhino, it's also working on other platforms like Giraffe. If you have never heard of Giraffe, please have a look at it. It's a very interesting platform that combines economic, financial measures, financial sort of like aspects of design, as well as our wind comfort and performance predictions. We again see the same sort of like principle in infrared, being able to manipulate design very quickly and immediately seeing wind simulation results. Again, these simulation results would normally take 3 hours to run, and that's what I think is important to sort of like specify. If we go to the next slide, we can then think of a different way of working with designs. Instead of like being able to just like iteratively check different options, we can run thousands of designs, and then within those thousands of designs options, we can identify our performance sort of like regimes, where we perform better, where we perform less, identify our performance objectives, and then actually come up with solutions that are coming from this solution space and not from our manual design options. Of course, we can continue in manual design and have this back and forth dialogue between the human ingenuity and the computer algorithmically produced intelligence, which is what we see here, is one part of what we're doing in the City Intelligence Lab. Again, combining some of our AR capabilities here. So just next slide, perhaps we just wrap it up here. Here's the team behind Infrared, a lot of really bright people, PhD students, and Theodore Galanos, our expert from Kuala Lumpur, and Reinhard Koenig, who's leading also the codec project in AIT. So more on our website. If you go next slide, and maybe one slide more, where you can see sort of like the website and my email. If you want to get in touch to organize like a way to access Infrared, to have a demo, or to like maybe work with it, please let us know. I'm always here. Thank you very much for the time. I hope I wasn't much longer than 10 minutes.
Fantastic. Thank you very much, Angelos. You have presented an amazing infrared tool. It's very promising. I wish you a lot of success with it. And thank you for your patience and this live from Vienna. Now, I would like to ask Alfonso to share with us his vision on digital tools and how he uses these tools to reduce carbon footprint in the building area. Thank you. The floor is yours.
Thank you very much again for that very clear presentation. I want to talk about digital technology and frugality, and I want to do that through 3 different aspects. First of which is design, and the second is material usage, and the final one, waste management. We have all resented amazement at the gaze of structures that have been designed using parametric tools. They are not only beautiful, they're also extremely efficient in terms of mass and material usage, and therefore their potential for mitigation of emissions is great. They also represent an inflection point in terms of how we design and how we work, and Angelos has just shown us how extensive that change is. We no longer use technology as a simple tool, as a hammer. Technology is today used as a partner. We co-create, we co-design with technology and machines. And machines, as you could see from Angelos' presentation, are learning, and this movement is accelerating. The big challenge it poses is it puts emphasis on how difficult it is to change the way we work with our peers and other stakeholders. If you ignore the reddish lines, we all know that in the early stages of the design, this is where our influence to impact climate change and maintain cost at an acceptable level is degraded. And as we go along with the project, our ability to have a real impact decreases. In terms of the change for an architect or an engineer that technologies such as BIM imposes, you can see that we used to spend more time doing the construction documentation and not really the preliminary design or the detailed design. And that is the kind of shift. It doesn't look like a big shift, but it's actually a change of biblical proportions, because it also changes the way we need to contractualize with other parties and the way we need to organize ourselves. So it's the human aspect, I guess, of things. Digital parametric tools such as the ones you've seen the latest technology with Angelos, but they have been in place for about 2 decades now. 10 years ago, we designed this beautiful store in the left bank of Paris. It's a store that was built upon a Art Deco pool. Now, the pool was forgotten from the registry, and actually the building was listed during the instruction of the construction permit. So we had to pay extreme attention to load and load distribution. We use parametric design to create the wooden structures that you see here. They're obviously very beautiful, they mimic nature, but they're also very efficient in terms of weight and mass distribution. And again, a very challenging endeavor, since the pool, as you can see from that little image, has to be found in the state. The entire project is a reversible project. One of the things that my colleagues mentioned, especially Arthur, is the importance of the data collection and treatment process. It is not something completely new to us. Half of the buildings that you see in this city were built using a kit of parts. The Baron Haussmann had 49 options for architects to play with, and it gives a sense of consistency across the city, but also a very efficient and sustainable city. And data is at the basis of plugins that we can now add to tools such as Revit, plugins that can help us not only understand the physical functional attributes of the impact of the built environment into the environment and the environment into the built environment, but also the financial aspects. We've seen an increased number of solutions coming into the marketplace. I'm just showing you 2 of them, Synapse and Vabi, which are 2 plugins that help us understand what are the financial implications of design moves and effectively bringing together the world of architecture and the world of engineering with the world of finance analysis. But let's not forget the human aspect. Behind the tools, we have humans. At RDAI, we've been working for several years now on a very extensive database of products. So we're not only able to look at the intrinsic quality of products, but also skills. This is an international database that lists sustainable practices around the world for the projects that we design. And again, it's not only the tool, the materials, but also the skills and the know-how. So very importantly, the second aspect I wanted to mention is material usage and how technology can help us better understand and reduce carbon emissions through optimization of material usage. Something that you see very clearly on this concrete slab. Now the problem that we face today is that this optimized slab is not cheaper than the non-optimized slab, and this is the reason behind this is there is a process that conflicts with the current process. But I'm confident that in a not too distant future, the cost will be reduced, such as the materials that go into it. I couldn't resist to show you this table. This is a reused stone-based table that we designed, not only beautiful, but also sustainable intrinsically. And the other aspect that I wanted to share with you is how we can use technology to better manage waste from construction sites, particularly. And the companies that you see here are all based in France, in Paris, but obviously this is a global phenomena. We've seen the development of platforms, numerical platforms that allowed us to be more efficient with materials, paint from a construction site that are not used and then reused in a second construction site, just to give an example, windows, slabs, you can think of many construction products that can be optimized and reused across different sites. And this is something that has a great impact. Now, I wanted to have a final word before we enter into the conversation with our colleagues and questions from the audience. The role of education, the things that we've been advocating collectively here today may seem obvious for us. We still struggle convincing people that seem to be reluctant to the development of technology, or even to the fact of, even to the evidence of climate change. But make no mistake, this is absolutely not the case with younger generations. I see at my level a very important generational gap between me and younger people working in my practice. And I know that new generations have this embedded into their curriculum. And this is really, really important. It will dramatically change the way we design things in the future. I've put it here, a couple of references, some of the books that inspire me and help me to build this presentation, which I hope you have enjoyed. Thank you very much.
Thank you, Alfonso. Thank you. It is clear that technology can help to break the silos between the different stakeholders to better design and ultimately build and renovate the building environment. So, gentlemen, I think time is running. Thank you for your conference. I would maybe conclude and sum up with the key points we have leveraged. First of all, the current pandemic, COVID-19, has accelerated the drive towards sustainability. And we can see that there is a new emphasis on the tools to allow better integration of sustainability principles. Second conclusion is that the silos of our industry and the poor levels of education remain a key challenge. And the third would be that the good news is that the main drivers we face today are organizational. We have the tools, we have the knowledge to overcome the challenge posed by climate change. So, Arthur, Angelos, from Vienna, and Alfonso, I would like to warmly thank you for your preparation, for your speech, and for the key learnings you brought us. Thank you also to all our listeners for your attention, and I wish you all a very nice and fruitful day today in BIM World and Low Carbon World. Bye-bye.
Thank you.
Bye-bye, Angelos. Thank you.